There it goes. All right. So if we were to do this problem, like using what we've learned already about multiplicity and finding the factors and stuff like that, what would you guys write for this one? You would say y equals x minus 2, and what's the multiplicity on that root? 1, yeah, so it goes straight through, and then what's the other one? X minus 4, and also to a 1. So if we were doing the problems that we've done before, we would say that we were completely done with this, and we didn't actually write down what this form is called, but this is the linear factorization form. And whenever you see that form on a test, you should like that because you just have to write it like this and you're done, and it's very easy to write. So we like that. Now, if you look at the instructions, they say find the standard form, and for us, we're going to kind of say boo every time we see that because standard form means you have to FOIL it out. You have to multiply everything out. You can't have parentheses. So that means we got to FOIL this. Or you could use the box. We're actually going to start using the box a lot today because we're going to be multiplying things that are kind of complicated to multiply. So if you FOIL this, we get x times x is x squared. X times negative 4. Negative 2 times x. And then negative 2 times negative 4 plus 8. So for this one, we would say the linear factorization form was x minus 2 times x minus 4. The standard form is x squared minus 6x plus 8. So those are two different equations that represent the same graph. So now we're going to know two different ways to write the equations. That means the instructions of the problem are really important because you want to know if you have to do the work to multiply or if you can just put the parentheses and call it good. Okay, how about the next one? If we were to write it the way that we've been writing the problems, what would we say? X plus 1. X minus 3. Squared. Okay, and I can see that it has an up arrow first and then it has a down arrow, so it's a negative problem. Okay, so if we were doing the linear factorization, we'd be done. That would be the answer. But we are not doing the linear factorization. We want the standard form. That means we have to multiply this all the way out. So that means I'm going to have y equals negative x plus 1 times x minus 3 times x minus 3. And can I multiply all of those at one time? No, I can't. I got to pick two. So we're going to leave the negative till the end. We're not going to deal with that yet. And I'm going to go ahead and FOIL these two right here. So I've got x times x. Marvelous. And then x times negative 3. And then 1 times x.
X squared plus 2x minus 3.
You're so close. Do you see what you missed? Minus 3 at the end.
That's what I said. X squared plus 2x minus 3.
But it's not plus. Minus 2x, yeah. Okay, so we still have the negative in the front. Now we have the x minus 3 on the end. What I have found is that when students try to FOIL problems like this, they often get confused. It just makes a really messy looking problem. So if you are very committed to FOIL and you definitely want to FOIL, the way that you would FOIL this is you would take the first one and multiply it by this one and this one. Take the next one, multiply it by this one and this one. Take the third one, multiply it by this one and this one. That's how you can FOIL it. What I would say is that even as a math teacher, when I start to see bigger things like this, I use the box. And I like to use the box to multiply because it puts the like terms near each other and it's easier to combine them when you're done. So since we have 3 things being multiplied by 2 things, I'm going to make my box a 3 by 2 box. And again, if you want to use the FOIL method, you are more than welcome. I just don't like it for bigger things like this. So we have x times x squared. So this one will be negative 3x and then the 9. Okay. So, and what you'll notice is that the like terms are kind of on diagonals with each other. That's one of the reasons I like doing the box for these. So we still have that negative in the front. And now we have x to the third. And we have negative 5x squared. And we have positive 3x and positive 9. Now you can distribute the negatives. So we've got y equals. Anybody? Yep, you're good. X to the third where x cubed works. Plus
5x squared minus 3x minus 9.
All right, so we have two different ways of writing this answer. We have the linear factorization, which I think you guys can see we might prefer that way. It's a little bit easier. And then we have the standard form. They represent the same equation. So the way that we know which one to write is we just read the instructions. All right? So if it says linear factorization, we go the easy route. If it says standard form, we got to multiply. All right. What would we have for the next one using the linear factorization form? X plus 5 x plus 1 and x minus 4. Okay. And these are all multiplicity of 1, right? We can tell because it goes straight through, straight through, straight through, straight through. Both arrows go up. What does that tell us? Positive in the front. All right, now what's a pain in the butt about this problem already? There's a lot, right? So what you'll notice about these is when you write it in the standard form, it's not necessarily a difficult math process. It is tedious, however. It is very tedious. Okay, what I want you to do is I want you to take these two and FOIL these two together. And I want you to take these two and FOIL these two together. All right, we're going to do those two first, and then we'll take our answers and multiply our answers. So once we've multiplied these two out and multiplied these two out, what do we have to do next with these answers? Yeah, we have to multiply them as well. So if you are a foiling person, you are welcome to FOIL this. You'd have to do this first term times this one, this one, this one. Then the middle term times this one, this one, this one. Then the last term times this one, this one, this one. All right? Yeah, and I don't like that. I like the box because it organizes the information for me. So how big does my box need to be?
3 by 3.
3 by 3. So we've got 3 terms times 3 terms. So x squared, 6x, 5. And it doesn't matter which side of the box you put them on. You'll get the same answer either way. So x squared times x squared is
x4.
X to the 4th. X squared times 6x.
X squared. Cube. Yeah.
X squared times 5. Negative 7x times x squared. Negative 7x times positive 6x. Negative 7x times positive 5. 12 times x squared. 12 times 6x, 2x. 12 times 5, 16. Okay. Did you guys all get your y equals when you wrote your answer? Y equals? Okay. So we got x to the 4th. What do we have for x to the 3rd? Minus 1, x to the 3rd. Or you could just say minus x to the 3rd. You don't have to have the 1 there. And then what do you guys have for x squared? Negative 25, x squared. How about for x?
Plus 37.
Plus 37x, and then plus 60 at the end. All right, did we get it?
Yep.
Okay. How do we feel about these problems? Annoying, but can we handle them? We can handle them? All right, go ahead and flip the page. All right, so the answers on the previous page, all of those x-intercepts were nice x-intercepts. All of them came just from factoring. None of them would have come necessarily from the quadratic formula, or you didn't have to use the quadratic formula, and I know that you didn't have to use it because none of them had square roots in the answer. They were all just whole numbers. So factoring was great for the front page. However, we have looked at problems that have complicated answers, so now we're going to look at those. So if you think about the quadratic formula, that is negative b plus or minus the square root of b squared minus 4ac all over 2a. And when you do the quadratic formula, you get answers that are irrational. What does irrational mean? No, they could be.
They don't make nice numbers.
Yeah, they don't make nice numbers. Like the square root of 16, that's a nice number. Square root of 12, for instance. That would be an irrational number. Square root of 5, square root of 7. Those are all irrational. And then what's the other I word that we would get? Imaginary. So those are the two types of answers that we get from quadratic formula problems, where you have to use the quadratic formula to get the x-intercepts. And whenever we have irrational and imaginary answers, they always have a plus minus, right? Because there's a plus minus in the quadratic formula. So that means that these messy answers that we get, they come in pairs. There's the plus version, there's the minus version, there's always a set of 2, all right? So go ahead and put that in bold or highlight it or something. They come in pairs. So the nice answers that we get from factoring, those you can have an answer of 5 and then an answer of negative 2 and then an answer of 1. But when we start to talk about irrational answers, if you have positive square root 5 as an answer, then you also have negative square root 5 as an answer because they come in pairs. If you have 3 plus 2i, you also have 3 minus 2i because they come in pairs. All right, so for this one, we have our first set of irrational answers. So they say that here, the decimal that we would get for the x-intercept right here is the positive square root of 2. The decimal we would get over here for the x-intercept is the negative square root of 2. So if we were to write the linear factorization, and we were to put these in parentheses, what would our first set of parentheses say? Plus
2.
square root 2, right? So we're not going to put the decimal, we're going to put the actual number, which is square root 2. And then what should we put for the other one? X minus square root 2. So there's the linear factorization, but is that what they were looking for in the instructions? No, they wanted standard. So what does that mean we have to do? We have to FOIL it or use the box. You can FOIL it or use the box. It looks worse than it is. So give it a second. So if we start to FOIL it, we're going to have x times x is x squared. X times negative square root 2 is negative square root 2x. You don't actually have to do much. Then we have positive square root 2 times x. So positive square root 2x. And what do you guys see about those? Those are going to cancel out, so things are getting nice. And then we have positive square root 2 times negative square root 2. And I know I've got a positive times a negative, which makes a negative. And square root 2 times square root 2 is square root 4. That's just 2. Okay. So what are we left with? X squared minus 2. Did you see how it didn't turn out as bad as it looked? And when you do messy answers like this, when you have nasty looking x-intercepts, they will always do that, where the nasty stuff will cancel out and you end up with a nice clean answer. Works out that way every single time. All right. So we're going to move on to problems that don't have pictures in them, that just have words as the instructions. So here it says that to find the standard form, so we have to multiply all of it out, of an equation of a second degree polynomial. What does that mean if it's a second degree polynomial? As an x squared, it's a parabola. It means when you write the equation in standard form, you're going to see an x squared as your highest exponent. It also means that we have 2 answers for x. If you guys remember how whatever your degree is, that tells you how many answers for x that you have. Okay. So they told us that one of the roots was negative 3i. That's an imaginary root, so we know that those come in pairs. So if you have negative 3i, what else do you also have? Positive 3i. Okay? All right, let's go ahead and write our parentheses. So we're going to do our linear factorization form first. And what would we have in our parentheses?
X minus 3i.
So x minus 3i would be for the second one. And x plus 3i would be for the first one. So you do the opposite sign. Now that's the linear factorization form. They want the standard form. So what do? We FOIL it out.
X squared plus I.
You're close.
Minus I.
So x times 3i. So 3ix. Yeah, it's kind of weird. But remember, what did I just say about the weird stuff? The weird stuff's going to cancel out, so we don't have to worry too much about it. And then we have positive 3ix, and what else do we have? Negative 3ix, so there it is, it just canceled. And then what do we have on the very end? Negative 9i squared. And negative 9i squared is really negative 9 times negative 1, and that gives us positive 9. So it's just y equals x squared plus 9. So the problem looked messy, but once we did all the steps, all the messy stuff canceled out, and you're left with a nice clean answer. All right, standard form of an equation with a third degree polynomial. So how many times should I write x equals? 3. X equals, x equals, x equals. Okay? The root is negative 2 with a multiplicity of 2. What does multiplicity of 2 mean for our parentheses? Squared, right? It's squared. Yep. And that means that set of parentheses happened twice. So I'm going to put negative 2 for the first one, negative 2 for the second one. So that's a root of negative 2 with a multiplicity of 2. I wrote it twice. And then we have a root of positive 1 with a multiplicity of 1. All right, so if I write this with the linear factorization form, what should I have?
X plus 2 squared.
X plus 2. And I'm going to write it out twice. Why do you think I'm going to write it out twice this time? Yeah, I'm about to FOIL it, so I just want to make sure that I FOIL it correctly. Okay, so x plus 2, x plus 2, x minus 1. Okay. So which ones do you guys want to FOIL first? The first two? Okay.
Then 2x.
Plus another 2. No, what's on the end? Plus 4. So you can FOIL it, or you can use the box. If you use the box, it's got to be a 3 by 2, or you can draw a 2 by 3, because it doesn't matter which side you put things on. So if we did x times x squared, third. If we did x squared times -1, if we do 4x times x, if we do 4x times -1, 4 times x, and 4 times -1.
Why is it x cubed plus 3x squared minus 4?
Yeah, so if you look in your box, we can see we got the x to the third first. And then with the x squareds, they add up to 3. The x's cancel out. And then you got the -4 on the end. All right, go ahead and flip the page over. All right, it says second degree polynomial. So how many times do I write x equals? Twice. X equals, x equals. All right. And it says we have a root of 2 plus 5i. And this is imaginary, so we know these come in pairs. So what's the other one? 2 minus 5i. Now, why is it only the middle part that changes? Does anyone know? How come I didn't say -2?
Because -2 is a real number.
Well, +2 is a real number as well, so these are both the same. So why does the sign just change in the middle? Why doesn't it change in the front as well?
Because they're going to cancel out eventually.
They are going to cancel, but think about where did those answers come from? What must they have done to get those answers? They must have done the quadratic formula. Yeah, and do you guys see where the plus minus shows up in the quadratic formula? Does it show up in the front?
Yeah. Well,
No, it's a minus in the front. It shows up in the middle. So that's why when you're doing two answers, the positive and the negative version show up in the middle because they come from the quadratic formula, and the quadratic formula has the plus minus in the middle, not in the front. Does that make sense?
Mm-hmm. So that's why this doesn't happen at the third degree.
So that's why this one, why the 2 stayed exactly the same, and it was just in the middle. Yeah. All right, so we're going to start off with our parentheses for our linear factorization form. So now you have to be careful because you always have to make sure you have an x in there. And you have to make sure you do the opposite of both of these things. So the opposite of positive 2 is negative 2. The opposite of positive 5i is negative 5i. And then we start with an x. The opposite of positive 2 is negative 2. The opposite of negative 5i is positive 5i. So when students do these, I tell them, do not shortcut this. Always write out x equals first and then change your signs as you put it in the parentheses. Because I have a lot of students write this in the parentheses incorrectly if they skip that step. Okay, so just I would say on this one step, don't try to save time or space. Just write it out, x equals, and then change the sign. All right, now this time we have 3 terms times 3 terms from the very beginning. So I'm going to go ahead and use a box to multiply these two together. Now, what did I say about the messy ones?
You're going to cancel out.
All the messy stuff goes away. So we are about to have lots of messy stuff, but it's all going to disappear. We're going to end up with a nice answer. So we have x times x, and x times negative 2, and x times negative 5i, which is our first messy thing. So we got negative 5ix for that. 2 times x, negative 2 times negative 2, negative 2 times negative 5i. What does that give us? Negative 2 times negative 5i. 10i, good. 5i times x. 5i times negative 2. And then 5i times negative 5i. 25i squared. And what is that actually? That's actually 25. Okay. What do you guys see about the messy stuff in there?
They cancel out.
Yeah, we have a positive 5ix that goes away with the negative 5ix.
X squared minus 4x plus
Yeah,
25.
Don't forget the 4.
Then we should just get I.
And then the 10i and the negative 10i cancel, right? So we get y equals x squared minus 4x. And then we have a 4 right here and a 25 right there. Plus 29. Mm-hmm.
Alright.
So even though it looked messy to start with, we still had a nice answer at the end. And that will happen every single time. Always nice answers. The next one says, write the standard form of a polynomial. And they didn't tell us what the degree was, so we have to figure it out. All right, so I'm going to write x equals, what is one of the roots they gave us? 4i. Now those come in pairs, so if they gave us 4i, what has to be there? Negative 4i. And then they also told us negative 3 square root 6. So what else has to be there? Positive 3 square root 6. Okay. Now when you do problems where they've got messy sets, you have to FOIL the messy answer with the other messy answer that goes with it. So I would not take these two and FOIL them together. That would be a terrible idea. That makes your problem horrible and you will cry as you do it. If you do these two, then the messy stuff will disappear. And if you do these two, the messy stuff will disappear and your life will be happy. Okay? So I'm going to go ahead and write out my linear factorization. I've got x minus 4i and x plus 4i. And then over here I have x plus 3 square root 6 and x minus 3 square root 6. So I know that for my life to go well with these, I want to FOIL these two together and I want to FOIL those two together. Because you have a positive times a negative. Yeah. So I think the hardest part about this is when you multiply the 3 square root 6 times the negative 3 square root 6. And if you guys see what I did there is I said 3 times 3 is 9. And square root 6 times square root 6 is square root 36. And then I said 9 times 6 is 54. What do you do once you have successfully FOILed these two?
Well, those two.
Yeah, FOIL these two. And since this is 2 times 2, if you want to FOIL it, you could use the box too if you're feeling more comfortable with that.